Welcome to the image processing series. In previous video, we looked into nearest neighbor interpolation. If you haven't watched it, make sure you do now, as this video has concept relating to it. To understand bilinear interpolation, let's talk about linear interpolation first. In linear interpolation, unlike nearest neighbors, where the new value depends only on the single old value, the new value depends on two other values along the axis. The farther value has lower weightage to the pixel intensity, and the closer value has more weightage to the pixel intensity of the new value. For example, if the pixel is at 0,0.75, it implies 3/4 the distance from the left pixel and 1/4 from the right pixel. So obviously, the right pixel which is near has more weightage and contributes more to the unknown pixel value. Now, if we perform the same operation on both the axes, that is, both the column level and row level, we get bilinear interpolation. So again, we want to upscale our 2x2 image to 4x4 image. When we try to overlay the output 4x4 image onto the 2x2 image, we run into a problem. For P1, there is no values to its up or the left side. As said earlier, to perform bilinear interpolation, we need pixels in all four sides. So we first expand the original input image by adding padding to its sides. Here we simply duplicate the border pixels to get the padded new input image. One thing to be noted here is that the input image is the one in center and the sides are padded values. Now we begin marking the coordinates of the new input image. Here the corner left of the 2x2 image, which is at center of the new padded image, gets the coordinate of 0,0. The pixel on the left and top of it gets negative coordinate values. Now we move on to our output image. The output image is overlaid on top of input image like we did in the previous video. But note that here the padding is not considered part of the input image. From the figure, we can infer that P1 of output image lies in the coordinate 0.25, 0.25. To calculate the weights, OpenCV uses this formula. Now let's go through each of these terms. So dx and dy are the row and column values of the output image. P1 lies at row 0 and column 0. So both dx and dy are assigned values of 0. The value of fx is calculated as follows. Similarly, Fy is calculated. The values Fx and Fy are the weightage values for the pixel P1 from the left and top. So to get the weightage from right and the bottom pixels, we calculate 1 minus Fx and 1 minus Fy. Here, the weightage value is multiplied with the value of pixel present in its side. After calculating, we get the value of A and B as 10. Then we again perform linear interpolation along y-axis between A and B points having values of 10. Here we take the Fy and 1 minus Fy values and the pixel present at top and bottom are A and B respectively. Again, after performing linear interpolation, we end up with 10, the final value of P1. Similarly, the pixel value is calculated for all the pixels in the output image, and we end up with a final upscale image. And that's how bilinear interpolation works. Thank you for watching.